Let's take a look to this. Acrylonitrile is produced in the reaction of propylene, ammonia, and oxygen. The feeds contain of, okay, this is the feed. So we have a reactor. Like to extract all the information throughout the block diagram. It's easier for us to extract the information. So please practice to extract all the information through this diagram. That easier for you to understand a given problem. Okay, the feed content of, okay, so I denote it as, okay, maybe we can use the molecular structure here. So we have 0.1 propylene mole propylene, and we have 0.12 mole ammonia, 0.7 mole air. So air here consists of, we have 0.21 mole oxygen, right? So the remain is 0.79 mole nitrogen. So this is the for air, 100 mole. Determine the reactant, which reactant is limiting. Okay, so we have 3 reactants, so we need to identify which limiting reactant, synthesized by which of each or other reactants is in excess, and molar amounts of all product gas constituent for 30% conversion of limiting reactant. So we have N1 here, mole, and then N2 mole ammonia, and 3 mole oxygen, and 4 we have N5 mole H2O. This is how we will try to extract all the information through the diagram. So we need to start with feed oxygen here. So feed oxygen, because oxygen also will be produced at the output stream here. So feed oxygen here equal to 0.78 mole air here. So we're gonna have air here, 1 mole air, to 0.21 mole oxygen, right? So we can have this oxygen is mole. So this is the 16.4 mole of air. So to prove which is the reactant is limiting here, based on the stoichiometry we have, if we have 1 mole of example propylene, theoretically we should have 1.5 mole oxygen, right? So if we have N here, oxygen, over N of propylene, C3H6 equal to, what is the N here? 3 mole per propylene, we have 0.1 mole. So it turns to 1.64. So theoretically, we should have one more, right? So it higher than 1. So we can say that oxygen is excess, because they calculated based on the real process given here is we provide the excess amount of the oxygen compared than required based on this theoretical. So the reaction here is the theoretical, which based on the stoichiometric pattern. How about we done with the oxygen? How about the ammonia? So ammonia, if based on the propylene, so 1 propylene require 1 mole ammonia. So if we calculate the operational, so N ammonia over N propylene, so we should have the ammonia here 0.12 times 100 over ammonia propylene, we have 0.1 times 100 equal to, okay, this is after calculator, equal to 1.2. So 1.2 or sit than 1, higher than 1, sure. Ammonia also excess. So if we consider here, how about the propylene here? Okay, propylene should have the same amount with the ammonia, but the given propylene here is much lower. So the propylene is limiting reagent. Okay, now we have done here. Okay, the molar amount of all product. So to perform this, we need to use the given information is 30% of conversion of limiting reagent. So the limiting is propylene, right? So we need to proceed with this here for the mole of ammonia stoichiometry here, because we already determined it based on the real. So we have 10 mole ammonia, 1 mole propylene. So the ammonia is 1 mole ammonia based on the stoichiometry. So we can get 0.1 mole ammonia. Okay, this is based on the stoichiometry. So if we calculate the stoichiometry of oxygen based on the stoichiometry, okay, we have 10 mole. So 1 mole propylene equal to, for we have 1.5 mole oxygen, so it turns to 50 mole O2. And then we can determine the excess O2 here by comparing the feed here to the stoichiometry or the real here. So we have 16.4 minus 15.0 equal to over 15.0 equal to, or times 100%. Okay, the excess about 9.3% excess. Same goes to excess ammonia. So based on the actual amount here, we have 12 here, 12.0 minus, what is the calculated here? The calculated here is 0 over 10.0 times 100%. So we have about 20% excess of ammonia. And then, okay, for fractional given is, or fractional conversion given is 30%. So we have 30%. So 1 minus F, we have 0.7. So how to calculate? Because it based on the limiting, right? So we need to consider the propylene ends. Propylene out here equal to and propylene in minus the, because we only have one reaction here, or it turns to limiting. So limiting reactant here we have, or the based on the fractional, it turns to, this is if we consider based on the limiting reactant. So we can have 0 equal to n out equal to the operation equal to NCH3. This is how you relate with the fractional. So we have NCH3 operation equal to 7, then it turn to 7 mole propylene. So and if we use the based on the need to calculate the, so we need to use this, calculate it. So this is our output here. It turns to, for the first, so 7 here equal to input here we have 10, right? Minus excess limiting here. So we have equal to 3. So by using this, you can solve the other here. Example, ammonia N2. NH3 equal to, and ammonia, the product, in the input here we have 12, right? So equal to 12.0 minus 6 ammonia at the reactant ammonia. So we have equal to, you can get the value here is 9.1 NH3. How about N3? O2 equal to 16.4 minus, we have 1.5 So just insert this value. We can get the value for ammonia is 11.9 mole O2. How about the next 4CH3N? We can get. Okay, for this, there is no reactant here. So we can have this only one, right? The value is, because it as a product, so the value is positive. It turns to 3 mole. H2O equal to 3. So mole H2O here equal to, because H2O also we not have the H2O at the reactant, so it turns to positive 3. So equal to 3 times 3 into 3, 6, 9 mole of H2O present. So this is how you correlate it.